Today we're going to be learning about how voltage, resistance, and current all interact and depend on one another using something called Ohm's Law, which was created by someone named George Ohm, which is this guy right here. Basically, George Ohm is the guy who determined electric current, resistance, and voltage all depend on one another in a DC circuit, which, as we know, DC stands for direct current, or current that only moves in one direction. So he came up with this law, and he said that our voltage is equal to the current times resistance. And using this basic equation, you can find out how one affects the other at any time. So let's take a look on our physical science reference tables to see where we're going to be focusing our attention. So if we're on the back of our reference tables, and we're looking at the very, very bottom, we see this equation here. That's our Ohm's Law equation. And you can see that we have it in two forms. We have the basic form, which we've seen already. Voltage is equal to current times resistance. And we have a different form. It's the same thing. Current is equal to voltage over resistance. It's the same thing, just worked out differently. We might be using one or the other. Let's try some practice problems. What you should be doing during these practice problems is following along with me, doing the work on a separate sheet of paper, so you have something to refer to when you're doing your classwork and homework sets today. So what we have here is a toy car with a resistance of 20 ohms is connected to a 3-volt battery. How much current flows in the car? Well, what I'm going to do is just use my basic equation. Voltage is equal to current times resistance. I'm going to plug in the information I know. I'm going to include my labels when I do this. So what we have is 3 volts is equal to current, which we don't know what it is, times our resistance of 20 ohms. Now this symbol here is called an omega symbol, and it's a shorthand way for us to write ohms. Here's a little bit nicer drawing of it, of the omega symbol. Okay? So now all we have to do now is solve for current. So to get our current by itself, we're going to divide each side by 20 ohms. And you end up with 0.15 amps of current. Pretty basic problem, but make sure you show all of your work, right? We wrote down our equation, we filled in our numbers with the correct units, we showed how we solved it, and we have our answer with the correct units. Let's try another one. Here we have a toaster oven is plugged into an outlet that provides a voltage difference of 0.12 kilovolts. What resistance does the oven use if the current is at 10 amps? Alright, so I know that I'm looking to find resistance. It says, what resistance does the oven use if the current is at 10 amps? Okay? So we can use our basic equation again. Voltage is equal to current times resistance. Now, I can't use this voltage yet because it's in kilovolts. That has to be converted. So let's just do a basic conversion here. So we have 0.12 kilovolts. Set up our goalpost. We know that kilovolts goes on the bottom. We know that volts goes on the top. Kilo is larger than the volt, so it's number 1. There's 1,000 volts in 1 kilovolt. When we do this, we will multiply the top and divide by the bottom. When that takes place, kilovolts cancel out, and we end up with 120 volts. So that's the number I'm going to put over here now. 120 volts is equal to our current of 10 amps times resistance. Divide each side by 10 amps. Resistance is equal to 12 ohms. Again, to show this correctly, I showed my formula. I showed how I converted 0.12 kilovolts into volts. I plugged my numbers in, I showed all my units within my numbers, and I have my answer with the correct units. That's the work that you need to show for every problem. Let's talk about what your work is today. Today for classwork and homework, you should be working on this sheet, Ohm's Law calculations, front and back, 1 through 8. And you need to make sure you show all work. Okay, get to it.